All right, welcome back to some homework help. We're now into chapter 8, and we're going to work through part A of problem number 87. Okay, 87 asks us to write Lewis structures for the following: for the nitrite ion, the nitrate ion, and the molecular compound N2O4. I'm sorry, the nitrite ion, and N2O4. Not sure exactly what I just said. Okay, so let's start out with our nitrite ion here. And we'll start out by listing our valence electrons. So we get 5 valence electrons from our nitrogen. And we get 6 valence electrons from each oxygen. So we have 2 times 6. And we have 1 electron from this negative charge here. Okay, and that gives us 12, plus 5 is 17, and 1 is 18. So we have 18 electrons that we need to account for in our nitrite ion. So let's look at this. Let's start by putting a nitrogen here, and we'll put an oxygen on either side of it. But let's remember that it's an ion by doing this. Okay, so again, these brackets tell us that it's an ion, and this negative charge tells us that there's an extra electron in here, making an overall 1 minus charge. Okay, so far I've accounted for 1, 2, 3, 4 of my electrons. Okay, that's probably not going to do it here. But let's see if we can just assign the other ones and see where we're at. So we have 2, 4, 6, 8, 10, 12, 13, 14. Wait a minute, I didn't do that right. 2, 4, 6, 8, 10. That's better. 12, 14, 16, and 18. Okay, now if we look at this, we can see, well, my oxygen is pretty happy, this oxygen is pretty happy, but this nitrogen is not happy. It wants to have 80 electrons around it, and it only has 2, 4, 6. So our nitrogen here is not obeying the octet rule. So what we need to do is we need to take one of these lone pairs from the oxygen and move it in. Okay. So then I'm just going to come in here and I'm going to erase that out. There we go. And draw a double bond. Okay, now we say I've got 2, 4, 6, 8, 10, 12, 14, 16, 18. I have 18 electrons accounted for now. Everybody's obeying the octet rule, and I have an overall negative charge. Okay, now this isn't required here, but what we're going to do is we're going to work on finding some formal charges for this ion. I might not do it for all of them, but it's really good practice. So once you see it for this one, you won't need to see it for the other one so much. So the formal charge on this oxygen here, we're going to start by saying that there are 6 valence electrons that come from this oxygen, and it currently has 1, 2, 3, 4 lone pair electrons around it, and it has 1, 2 bonds. Okay, that means that it has an overall formal charge of 0. 0 is excellent. 0 is best. Okay, now let's look at the nitrogen. The nitrogen brings to the table 5 valence electrons. It has 1, 2 lone pair electrons on it, and it has 1, 2, 3 bonds. So 5 minus 2 minus 3 is 0. Another excellent formal charge. Okay, let me just add in here that I'm doing formal charge right now. Again, not required for this problem, but it's a good place to do it. Now let's look at this last oxygen here. It brings 6 valence electrons to the table. It has 2, 4, 6 lone pair electrons around it and 1 bond, which gives it a formal charge of -1. Now this is perfect. We have 0, 0, and -1. And this one -1 charge over all that we have for our formal charges matches the negative right here. So we have done a beautiful job on this ion, and we are pretty sure, very sure, that our Lewis dot structure is ideal. All right, now let's go ahead and look at our next one. I'll hold the paper up from under the shadow of the book a little bit. Now we have the nitrate ion. Okay, so we get 5 valence electrons from the nitrogen, plus 3 times 6 from the oxygen, and 1 from that negative charge there. Okay, so this gives me 18, 23, 24. So now I have 24 electrons to assign. Okay, so let's see how this is going to work. We have a nitrogen here, and we'll put an oxygen off of each one. Okay. Now I'm going to draw my brackets right away so that I can remember that it's an ion with a negative charge. There's an extra electron in there. And I'm going to start putting some valence electrons, some lone pair electrons around. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. So again, all of my oxygens are happy, but my nitrogen is not happy. My nitrogen is not happy because it has not enough electrons around it. So I'm going to do the same thing I did before, and I'm going to take one of these pairs and I'm going to move it down here to become a double bond. So let's go ahead and erase these out altogether and make a double bond there. Okay. Now I don't need to do formal charge for this one because I did formal charges over here, and it's going to be the same. So what I'm going to do extra with this one is I'm going to draw some resonance structures. Okay, now this should be pretty simple. And the question you would ask yourself is, well, I took a lone pair from this oxygen to move it in, but why didn't I take it from this one or this one? Well, there's really no reason why. I just picked one, which means that I can draw some resonance structures which would show if I had moved the lone pair from different oxygens. Okay, and this actually has a third resonance structure. Sometimes this gets tricky, doing this with a camera in one hand. Okay, so I have drawn 3. I have this one, and this one, and they're all identical except for the fact that the double bond is going from the nitrogen to a different oxygen. You can say, well, which one is it? Well, they sort of all happen sort of at the same time. Those extra electrons sort of float around and make a partial double bond character through all of them. So as one of my students told me yesterday, he didn't really want to know that. So if you don't really want to know that or really wrap your head around the idea of the electrons floating around, you don't have to, because we won't get to that until chapter 9. And you can just right now learn how to draw resonance structures that show that all of these are kind of happening and identical. Okay. Now we'll pull this out and we'll do one more in this video because it's getting quite long. We have N2O4. Okay. Now, one of the things the book tells us that it looks like O2N-NO2. So our N's are connected. Okay. And then we'll have something like this. Well, maybe. Might not end up liking this structure much. We'll have to see. So I jumped the gun here. What I really should have done first was count my electrons. So I have 2 times 5 from the nitrogens plus 4 times 6 from the oxygens, which gives me 10 here and 24 here. So I have 34 electrons to assign. Okay, so let's take a look here. So this is going to be my basic structure. And I need to figure out where the lone pair electrons are going to go and where there are going to be any double bonds potentially. Okay, so we would say, well, I have so I have 2, 4, 6, 8, 10. I have 10 bonds. I'm sorry, 10 electrons in bonds, 10. Then 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, and 34. Ah, excellent. Well, sort of. All right, let's take a look here and see what this one should be. Okay, so let me make sure that I counted them right for starters. Let's see, I have, well, first of all, I have 6 around each one of these, so that's good. That's 24. And then I have 1, 2, 3, 4, 5. Okay, so I counted those right. I have 34 electrons here, but I think that everybody can sort of see that the problem that I've got going on here is that my nitrogens aren't happy. They each only have 3, so that isn't going to work at all. Okay, so there's a variety of things that we can do here. I think that what I would like to see happen is I would like to see a double bond form on each of them. And I'm just going to kind of randomly pick one on each nitrogen and form a double bond like so. Okay, now I should be happy. Now I have 6 and 6 is 12, and 4 and 4, okay, that makes 20. Now let me make sure that I have enough bonds. So 20 plus 1, 2, 3, 4, 5, 6, 7. So 20 plus 14 is 34 electrons. Okay, and everybody is following the octet rule now. Okay, and again, you could draw a resonance structure here where these double bonds were here and here instead, or here and here, or here and here, and they'll be different. We would name these differently, but that would be a different class altogether. Okay.